let's explore reflections about the x-axis. So we'll start with the function, call it f, and f is defined by some formula, which we write as f of x. We want to know what can be said about the function defined by the formula minus f of x. Let's take a look at this. Here's how we picture f. It inputs x and outputs what we get when we plug x into its formula. And then this new function, which we'll call g, so a formula for g of x, is simply minus f of x. So this function g inputs x, and it outputs minus f of x. Is there any meaningful relationship between the two graphs? The graph of y equals f of x on one hand, and the graph of y equals g of x, which is simply thought of as minus f of x, on the other hand. Let's see. Let's look at a point on the graph of y equals f of x. So point on that graph, x comma f of x. We'll plot it right there. And we want to know where is x comma g of x. Where is that point in the plane? Let's see. G of x, the output, is minus f of x. Okay. So let me plot the point x comma minus f of x, which you know will be right there. So this is exactly, as we just saw, the point x comma g of x. So these 2 points are symmetric about the x-axis. And we can now conclude that the two graphs will be reflections of each other, reflections about the x-axis of each other. Let's do a concrete example. Let's look at the absolute value function. Here's the graph of y equals f of x. We'll simply write this as y equals the absolute value of x. And so the graph of y equals minus absolute value of x will be the reflection of this graph about the x-axis. Just like that.